So we're looking at Trig Lesson 1, and this is angles in standard position. And so we're in your workbook right now on page 137. So essentially, let's get through a bit of the terminology. And so we recognize that 360 degrees is going to be one complete rotation. Where does the rotation start with? So we're always going to be starting on with an initial arm. And the initial arm is going to be always, usually we'll put that on the positive x-axis, and the angle will be rotating in a counterclockwise direction. So you can see theta, and it is the terminal arm that is moving, so that's where the angle essentially finishes. And the vertex is our fixed point, which we're rotating about. So positive angle is what we will typically go in, and that's going to be in counterclockwise rotation. A negative angle will be a clockwise rotation. So we've got the initial arm, the terminal arm, and positive angle being counterclockwise. So that's most of the time, and occasionally you'll also see a negative angle that happens in a clockwise rotation. In terms of standard position, we are looking at the vertex being on the origin and the initial arm being on your positive x-axis. So the vertex is on our origin, or 0, 0, and the terminal arm is anywhere as it rotates around the vertex. So if we take a look below at this example, we've got an angle of 220 degrees in standard position. So if you imagine that we had our initial arm right here on the positive x-axis, and that terminal arm, almost like I guess it would be a broken clock going the wrong way, because it's in a positive direction, it is going counterclockwise 220 degrees. And so this is our angle theta of 220 degrees. So if we take a look, it says sketch the rotation angle in standard position and state the quadrant in which the angle terminates. Of course, let's just review. Quadrant 1 is going to be positive x and positive y. Quadrant 2 is going to be negative x, positive y. Quadrant 3 is going to have negative x and negative y, and quadrant 4 will have positive x and negative y. So if we take a look at 120 degrees, so again, it's not always nice just to draw in your initial arm, recognize where it starts, and then our terminal arm is moving that way, and it goes past 90 degrees and another 30 degrees. Again, the more accurate you can make it, a good estimation, and that will help your brain to think about where it is that you need to go, as well as the fact that the remaining distance is 60 degrees. So this is theta, which is 120 degrees. So hit pause and try the other two then. So for our second angle, 309 degrees, we started with our initial arm. Because it's positive, we're going in counterclockwise direction. 309 degrees is going to be 39 degrees into the fourth quadrant. And so that is our angle theta, which is 309 degrees. So again, that is going to be in quadrant 4. I'm going back to 120 degrees. We see that that terminal arm finishes in quadrant 2. For C, 17 degrees is just going up just a little bit there. And so that is still in quadrant 1. Okay. So in this particular case, it says draw the rotation angle in standard position. So they've already drawn in your terminal arm. So if you wanted to draw in your initial arm, this is a rotation of 150 degrees. So This is all they're looking for. It's for you to say that that is theta. In this case, we're looking at negative 210 degrees. So we recognize in this particular case from our initial arm at the positive x-axis, we're going around in a clockwise direction to get to 210 degrees. Hopefully, you're also recognizing that in both cases, our terminal arm are exactly the same spot. And so we call those coterminal angles. So they are angles that have the same terminal arm. How else can we achieve that is when we go over 360 degrees. And so if we're talking about 510 degrees, what's happening right here? Well, we go around 360 degrees, and then we cover an additional 150 degrees. So that gives us our theta is equal to 510 degrees. So how many coterminal angles could we have? Well, if we open it up to any angle, then that's going to be infinite because we can just increase it by 360 degrees. But since we want to look at the smallest positive rotation angle, that 150 degrees is called our principal angle then. Okay. And it says the principal angle will always have a measure between 0 and 360 degrees. Okay. So let's take a look at class example number 3. So they're just simply asking you to draw in point P that lies on the terminal arm of the angle of theta degrees, and just to draw in the angle. So let's take a look. Let's use our, whoops, whoa, not do that. Okay, so that's not cooperating. So let's just draw a sketch in our axes then. And so with a positive x and a negative y value to -4, I know that I'm in quadrant 4, and we'll just do a good estimate of this. So if this is 2, -4. So here's my point P, and point P lies on the terminal arm. So there it is, and this is 2, -4. And we know that my initial arm, let's use a different color, my initial arm is on the positive x-axis, and we are going in counterclockwise direction. So this is our angle theta degrees then. Okay, so hit pause and try part B then. Okay, so we've drawn in point P at -5, -1, and so then we know that the initial arm is on our positive x-axis, and it is going around in counterclockwise direction until we hit our terminal arm, which passes through the point -5, -1. So that is theta. Excellent. Let's move on then. So let's talk about reference angles. So reference angles are the acute angles formed between the terminal arm of the rotation angle and the x-axis. So you have to think about what, is it closer to the positive x-axis or is it closer to the negative x-axis? And so the reference angle will always be an angle that is 90 degrees or less. So if you take a look right here, so the diagram shows terminal arm of a rotation angle of 141 degrees. So this is our 141 degrees is our angle theta, and our reference angle is right here. So we'll call that theta r. That is our reference angle because that is between our terminal arm and the closest x-axis, which happens to be on the negative x-axis side, and that is 39 degrees. So let's take a look at class example 4. I'll do the first one with you and you can try the others. So 243 degrees we recognize is in quadrant 3. 243 degrees is 27 degrees away from 270. Or 63 degrees away from 180 degrees. So again, with a little bit of accuracy, so we're about 2/3 of the way through, so somewhere around here. And so we can see the rotation angle is going to be this whole thing, so that is theta. I'll use a different color. So for my reference angle, that terminal arm is closest to, again, that negative x-axis on this particular one. So this is my theta r, my reference angle, and the distance, the degree measurement between our terminal arm and the negative x-axis is going to be 63 degrees. Okay, so hit pause and try B and C on your own. So taking a look at B, we've drawn our terminal arm 337 degrees in quadrant 4, and our reference angle is going to be between the terminal arm and the x-axis that is closest, so that's our positive x-axis, and so this is theta r. And so since the rest of this, our angle in standard position is 337 degrees, then to complete that rotation, we're talking about 23 degrees to get to 360. If we take a look at C, 70 degrees is in quadrant 1, and so the distance between, or the measurement between our terminal arm and the closest x-axis is our positive one again, and so in this particular case, theta is the same as theta r, which is 70 degrees. Okay, so taking a look at class example number 5, we can draw a reference angle of 58 degrees in each of quadrants 1 to 4. So if we take a look here, so 58 degrees, so close to 60 degrees. So it's about 2/3 of the way. And so there's 58 degrees. We can reflect that into quadrant 2. There's 58 degrees. Reflect that again into quadrant 3 and then into quadrant 4. So in every single case, so this is my reference angle of 58 degrees. This is my reference angle of 58 degrees. And again, right here, and again, right here. So there are 4 reference angles of 58 degrees in each of quadrants 1 to 4. So if we're stating the rotation angle in each quadrant, so then in quadrant 1, when we have a reference angle of 58 degrees, that terminal arm would mean that we have an angle of, again, 58 degrees. In quadrant 2, if this portion is 58 degrees, so if we start at the positive x-axis as our initial arm, and we go into the second quadrant. If we know that we've got 58 on this side, then we know that it is going to be 122 degrees. It's going to be the rest of the way to 180. If we are looking at quadrant 3, so we know that at the negative x-axis, our terminal arm would have gone 180 degrees plus another 58 degrees gives us 238 degrees in quadrant 4. And then we know that the remaining amount is going to be 58 degrees, which means that if we've started at the initial arm, come all the way around, then we're looking at 302 degrees. Okay, let's take a look at letter C. So let point P 5, 8 be a point on the terminal arm of the rotation angle in quadrant 1. So then state the coordinates of Q, R, and S, which are on the terminal arms of the rotation angles in quadrant 2, 3, and 4, respectively. So hit pause and try to go through this one on your own. So if you're unsure, a diagram is always helpful, and you can see what happens when we draw those terminal arms of the rotation angles in the other quadrants. It is just a reflection into quadrants 2, 3, and 4 over the x and y axes. Excellent. So take a look at class example number 6, as well as class example number 7. I would always recommend just doing a quick sketch. The more accurately that you can sketch it, it gives your brain just an idea of what you're dealing with. If you label your reference angles, again, that's helpful to many to have that visual piece, especially while you're just learning these. So hit pause, try to go through them, and then I'll talk you through them as well. So let's take a look at class example number 6. So I've drawn in the sketches for us. So we know we're in quadrant 2. We have a reference angle of 25 degrees. So that rotation angle starting at our initial arm goes into quadrant 2. So we're almost at 180 degrees, but we're short 25 degrees. So 180 minus the 25 degrees then will give us 155 degrees as our rotation angle. In quadrant 4, if we have a reference angle of 60 degrees, again, we start our initial arm, we're going counterclockwise direction, and so we're almost at 360 degrees, but we're short 60 degrees. So in this case, we're 360 degrees minus 60 degrees, so we have a rotation angle of 300 degrees then. In quadrant 3, a reference angle of 8 degrees means that starting at our initial arm, we go past the 180 degrees by 8 degrees. So in this case, we're looking at 180 degrees plus 8 degrees, or a rotation angle of 188 degrees. In quadrant 1, we're looking at 39 degrees as our reference angle, and the rotation angle is the same as the reference angle when we're talking about quadrant 1. When we are in between quadrants 3 and 4, so that's often a question students have, is if you are actually on one of the axes, what quadrant are you in? And so in this particular case, we're talking about we are between quadrants 3 and 4. The reference angle is 90 degrees because you could say you're 90 degrees from the positive x-axis. You're also 90 degrees from the negative x-axis, but we're still starting with our initial arm and going in counterclockwise direction. So we've done a rotation angle of 270 degrees. Class example number 7 says determine 3 angles between 0 and 360 degrees. They had to give us a limit of 360 degrees. Otherwise, if we're talking about all of the angles, we've got lots of coterminal ones, and so there would be infinite possibilities. So we want the same reference angle of 256 degree angle, that being your rotation angle. So we need to figure out what the reference angle is. So you can see I've drawn in my terminal arm for an angle of 250 degrees. I've indicated my reference angle is right there. And so we know that 250 degrees, that's going to be how many degrees past 180? So 256 degrees minus then 180 degrees gives us a reference angle of 76 degrees. So that means that if I've already got quadrant 3 done, we want to talk about quadrant 1. In quadrant 1, the reference angle is the same as the actual rotation angle, so 76 degrees. In quadrant 2, let's bring out a different color. And then 76 degrees puts us right about right here. So there's my reference angle of 76 degrees, so we take 180 and go back 76 degrees, and so then we're looking at 104 degrees. So quadrant 2, we're talking about 104 degrees. Quadrant 3 we've already got, so let's take a look at quadrant 4. Quadrant 4, there's our terminal arm. Again, to come up with that so quickly, you can easily just reflect the other rotation angles or the terminal arms from the other quadrants. So again, right here we have our reference angle of 76. So that means we're 360 degrees short 76. So 360 degrees, write that out for us. So 360 degrees minus 76 degrees gives us then 294. No, that would be 284 degrees. Eraser. Yes. 284 degrees. Okay, so please complete the assigned questions and let me know if you have questions.